Sorry, folks. I have to stop this video three, early because my doorbell rang, so I have to answer it. Let me go ahead and do problem number 48 again. 48, finish it actually. 48, number 48. It says the angle is 10, obviously radians. Okay, and we're supposed to find an angle between 0 and 2 pi in radians, which is coterminal with that. So first, let me find out exactly where this, for my own information, where uh, uh, where this uh, where this angle is. And what I'm going to do is I'm going to divide this thing by 2 pi to see how many cycles going around is involved. So this thing is approximately, if you use a calculator, you get 1.59 cycles. So what it means is that you go around one full cycle because of this, and then you go almost zero point 0.6 cycle, almost half a cycle, somewhere there. So the angle that we're dealing with is right there. Now, if I want to know what this angle is, okay, what this angle is, all I have to do is say the angle I'm looking for, the red angle, is approximately 0.59 times 2 pi radians. Okay, so let me let me think about it. Well, let's see now. Uh, see this. It says almost half of a full cycle. So if I clean this up, we get approximately. Put this thing in my calculator. Here is. Let me go here. Let me go to my calculator. This answer -1 is going to be your uh, 0.59 that I was talking about, and you multiply it by 2 pi, because I have to multiply it by 2 pi to find the angle in radians. Okay, 0.59 full cycle in radians multiplied by 2 pi. So this is times 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 this times 2 times pi. So it's approximately 3.7 radians. So if you go back here, this is approximate, of course. This red angle is approximately 0.37. Let's see now. It says rounded off, so it's 3.712. Oh, sorry, not like that. That's a mistake. 3.712 radians. So the answer to the question about 10 radians is approximately that number. Okay, so let's go to the next one. What's the next one? It is 49. Number 49. It's 17 pi over 4. I'm going to write this thing as 4 pi plus pi over 4. Okay, so the angle that's given going around the circle twice. Let me use a different color here. So you start here, you go once, that's 2 pi. You go another cycle, that's 4 pi plus pi over 4. So right there, this is the terminal angle. We stop there. Okay, so if you want to find an angle between 0 and 2 pi, which is coterminal with that, all we need to do is to take this angle. So pi over 4 is the answer to problem number 49. Good. Number 50 is 51 pi over 2. So let's get through this. Okay, problem number 50. It says 51 pi over 2. Is that right? Yeah. Okay. So this, how many 2 pi's do I have here? So let me write it like that. Uh, let me write it like this. 50 plus 1 over 2. This is times pi. Okay, so 51, I wrote it at 50 plus 1. So that is 25 pi plus pi over 2. Okay, so let's think about this thing, what it says. It says, okay, go 24, let's think about it like this. This is 12 times 2 plus 1. So you go 12 cycles, 12 of them, and then 1/2 a cycle. There's 1/2 a cycle, which is 1 pi. So 25 pi means go around the circle 12 full times plus half of a cycle, and then keep going for pi over 2 right there. This is 12 times plus half a time or half a cycle plus pi over 2. So right there. So this, I didn't draw all of these loops, but what angle can I choose so that it's between 0 and 2 pi and it ends up with this as the terminal side? Well, it's going to be like that, all right? It's going to be like that. So the answer to problem 50 is 3 pi over 2. 3 pi over 2 is an angle between 0 and 2 pi, and it is coterminal with that weird number 51 pi over 2. Okay? Let's go and do these other problems, which are the different kind of animals here. So let me get rid of this. Go down here, see what it says. Oops, where are these? Okay, so we're talking about these circle problem. Find the length of the arc in the figure. So it's asking you what is this red arc, and we have a formula. We did this thing in class last week. So S equal to R theta, but watch out, this theta must be in radian, must be in radians. Okay, so first of all, 140 degrees, that means the angle, the leftover angle here is 220, right? 220 degrees. Converted to radian, that means multiplied by pi divided by 180. And then, of course, what that thing means really is 180 degrees. And then put the radius there. The radius is 5, I suppose 5 feet or 5 inches. It doesn't matter, 5 units. So the answer is 5 times 220 times pi divided by 180. Now, even if you don't put the degrees here, it's okay, because actually these 2 degrees can cancel each other out. So we have to go and put this thing in your calculator. Remind me what it is. 5 times 220 times pi. Where's pi? Is this the one? Right there. Divided by 180. And the answer is 19.19. If I round it off to the third digit, 19.199. So the answer is 19.99. Was it 19.199, which is rounded to third digit. Now, whatever the unit of this 5 is, if this was inches, this is going to be inches. If this was feet, this is going to be feet. The key is make sure that this theta is radians. Same kind of thing here. Now, notice that in this drawing, there is no mention of it says find the angle. Okay, so here we have this is number 52. We have S equal to R theta. Okay, so S is given to you as 10, R is given to you as 5, and theta you have to find. So theta is equal to, you divide it, you get 2 radians. There's nothing wrong with this answer. But if you're asked to supply it in degrees, what you need to do is you take 2, multiply by 180, divided by pi, and whatever you get is going to be in degrees. So this is going to be 360 divided by pi. Now I have to put this in my calculator. Yeah. So let's put that thing in our calculator. 360 over pi. 360 divided by pi, and this is approximately 114 degrees. So in this drawing, this angle theta is approximately 114 degrees. Now notice that you really need I didn't put it there, but you put it, there's a degree sign here, there's a degree sign here, that's why we get a degree sign on this side. Okay, what else have we got here? Let's do these problems quickly. Yeah. Once I do these problems, then I'm going to make another video segment for the remaining one. Find the length of the arc of a central angle, radius 10 meters. So what it's saying is that, look, we have a circle radius 10 meters, and the angle is 45 degrees. What is the arc length? What is this length? S. So S is equal to R times theta. This must be in radians. So 45 degrees is pi over 4. Radius is 10. So this is equal to 10 pi over 4. And if you put it in our calculator, 10 pi over 4, 10 times pi divided by 4, and you get 7.854 meters. So this is equal to 7.854 meters, which is exactly this thing. But we have replaced the value of pi. Okay, so let's do the other one. Let's get through these things. Okay. Next problem, number 55. Okay, number 55. Length of the arc subtends a central angle of 2 radians. So we have a circle here. We have a radius of 2 miles, a circle of radius 2 miles, and an angle that is 2 rad. Now, 2 rads means it's around 120 degrees. So it's actually doesn't look like that. 2 radians is about 120 degrees, but I don't care. So we're going to say S equal to R theta. This is 2 miles. Radius is 2 miles. This is 2 radians. This is 2 rads. This is 2 miles. And the answer is 4 miles. So this length is 4 miles. Actually, the correct drawing would have been something like this, but we really don't have to know that. So what's the radius of that? What is the arc length? It's 4 miles. Okay, so let's go to number 56. Okay, 56. It says, let me draw that thing. The central angle theta in a circle of radius 5 meters. So the radius is 5 meters, and it subtends an arc length of 6 meters. So this is 6 meters. What is this angle theta? So we write down S equal to R theta. We know that this is 6. We know that the radius is 5, and we get the theta. And theta is going to be 1.2 radians. Okay, it says both in radians and degrees. This is radians. So if you want to convert it into degrees, so it's going to be 1.2 times 180 divided by pi. You put it in your calculator, and you get an approximate value. So that's going to be 1.2 times 180. Let's see. 1.2 times 180 divided by pi. Second function, here is your pi, and enter. So it's approximately 68.755 degrees. 68.755. Approximately 68.755 degrees. Okay, so that takes care of these. Let me see now. I don't know, maybe we should do this one too. Find the radius of each of these. Find the radius of each circle if the area of the sector is 12. So, okay, so you say if the radius is here, sorry, if the the radius is 12, what's the area? No, sorry, if the area is 12, the area is 12, what is the radius? Now remember, last week we had a formula which was A equal to 1/2 R squared times theta. We are told that the area is 12. I'm doing 62. A. I'm doing this one. A. So 12 equal to 1/2 R squared, and theta is 0.7 radians. Remember, this must be in radians for this formula to work, and of course it is given. And so let's see now. R squared equal to, if you multiply both sides by 12 and divide by 0.7, you go 12 times 2 divided 0.7. This is 24 divided 0.7, and you need to take the square root of it. So let's go ahead and do this thing. So square root, where is the square root here? Right there. Second function, square root. And then parentheses. If there's any chance of making a mistake, you put parentheses there. So this is what, 24 over, let me actually do that, 24 divided by 0.7. It's under the radical, so there's no chance of making a mistake there. That's easy. And hit enter, and you get approximately 5.855 R equal to 5.855. If whatever the unit of this thing is, if this is inch squared, for example, this will be inch. If this is mile squared, this will be mile. So I'll just leave it like this, but unit is consistent, must be consistent with unit of A, that 12, whatever that area is. Okay, let's repeat this thing for the other problem. The other problem is the angle is 150 degrees. So what we need to do is we can use the same formula, except that we're going to have to convert that 150 degrees to radians. So this is still 12, 1/2 R squared, but I have to take this theta and write it in radians. So it's going to be 150 multiplied by pi divided by 180. So R squared is going to be, let's do a little bit of a cleanup here. This 0 cancels that 0, just to make my job easier. So it's going to be 24 divided by multiplied by 18 divided by 15 pi. Please make sure that you can do simple algebraic operations like this quickly. Uh, what I did, first of all, I canceled the zeros. Then I multiplied both sides by a 2 and an 18 to get rid of the 18 in the denominator, and then divided by 15 pi. Now you're going to put it in your calculator. Well, I can take this thing one step further. So this is 5 and this is 6, right? Both are divisible by 3, so that's what I did. So it's 144 divided by 5 pi. The only reason I did it is that, I don't know, square root, where is that square root? Right there. And what was it? It was, can't remember what it was. 144 divided by 5 pi. Okay. 144 divided by 5 times. This is where people can make a mistake when they do when use a calculator, but I'll let you work it out. Close the parentheses. We don't have to, but enter. So that's going to be 3.0278 if I round it. 3.0278, or equal to 3.027. If I round it, 3.028, 028, right, to 3 digits, it's going to be 3.028 right here. Unit consistent with unit of A equal to 12. If this is miles squared, this is going to be miles, etc. Okay, so we did this problem. Let me get rid of that. Okay, so let's get rid of the stuff that we don't want here. We did this, we did that. Delete these. Okay, number 63. 63. Find the area of a sector whose central angle is 1 radian in a circle of radius 10 meters. So we have a radius 10 meter, circle of radius 10 meters, and you're told that this angle is 1 rad. We want to find what this area is. This area is, okay? So area is equal to 1/2 r squared times theta. 1/2 r is 10, quantity squared, angle is 1. So this is 100 over 2, and this is 50. Unit consistent with whatever that 10 is, because the radius was 10 meter, this is 50 meter squared. Okay? Let me clean up some of the stuff here. Okay. We're going to do number 64. Same type of animal, probably. Okay, 64. The sector has a center angle of 60 degrees, so it says this is 60 degrees. The radius is 3 miles, and it's saying what is this area? Well, we have 1/2. Area is equal to 1/2 r squared times theta. 1/2. Radius is 3, so 3 squared, and theta is radian. 60 degrees in radian is pi over 3. So this is going to be 9 pi over 6, or if you divide it by 3, you get 3 pi over 2. And if you want actual numbers, so you just put that in your calculator, 3 pi over 2. Let's go here. 3 times pi divided by 2 is 4.712. 4.712. So this is 4.712. What's the unit? Mile square, square miles. Okay, so we did these. What else is left to do? These are 2 word problems, and I'm going to do it. Why don't we do it right now? These are not hard. Okay, so let's see. Did I miss something here? There's a problem missing. Oh, there's a problem missing. So let me do the word problems in a different video segment. Okay, I'm going to stop this.